Hey everybody, welcome to Conceptual Geometry, Lesson 2.6, Altitude of a Triangle. An altitude of a triangle is a segment drawn from a vertex perpendicular to the opposite side. So if you remember that word perpendicular from earlier in the unit, that just means forms a right angle. All right, in this diagram, I want to draw an altitude from angle B and then name a right angle. So from angle B, I have to draw a segment so that it's perpendicular. Well, that's not going to be perpendicular. That's not going to be perpendicular. Remember, perpendicular forms right angles. So I'm looking for this shape. There it is, slightly rotated. So I want to draw this towards the opposite side so that it makes right angles here and here. Okay, so again, we're just going to estimate. There we go. You can make up any letter you want. I'll just call that D. Now it says name a right angle, angle BDC. Obviously here there's two, BDC. You could also name this one here BDA. It doesn't really matter. Just make sure you name one of them. Okay. Notice the next figure. If I want to draw an altitude from B perpendicular to the other side, it looks like it's just that side of the triangle, doesn't it? And it is. This is an altitude from angle B. The right angle there would just be angle BAC. Now look at my third triangle. I need to draw a segment from B perpendicular. So again, we're looking for like that sort of intersection. Well, there's no way you can draw it over here. None of these are going to be perpendicular. So this is kind of a strange case. What you have to do actually is draw something that's outside of the triangle, like so. Which means we have to extend this triangle out, then draw an altitude down to that. And I would say angle BDC is a right angle. Now I want you to notice the different shapes here. This triangle is an obtuse triangle because this angle right here is obtuse. This triangle is a right triangle because this is a right angle. And this triangle is acute because all three of these angles are acute. So it turns out that our altitude in an acute triangle is always inside the triangle in an acute triangle. No matter what you do, the altitude will be inside as long as all three of those angles are acute. Well, in a right triangle, the altitude is always on a right triangle. So if you notice here, I'm going to draw the altitude to this side. Well, that's on it. If I draw the altitude to that side, that's going to be on it as well. And in an obtuse triangle, you can probably figure it out. It's going to be always outside the triangle in an obtuse triangle. And that's why we had to go outside here. All right, well, let's take a look at some algebra involving altitudes. In our first example, it says BE is the altitude to AC. So altitude is perpendicular, right angle. I have to draw a segment down that's perpendicular to the opposite side, forms right angles like so. It says BE. So I know both of these are right angles, and it wants us to name that point E. First part of the problem says find the measure of angle BEA. That's pretty obvious, I think. That's going to be 90 degrees. Measure of angle BEA equals 90 degrees. That's the first solution. And then it says if the measure of angle BEC is 132 minus 6x, BEC is this one, which is also 90 degrees. 90 degrees is going to equal 132 minus 6x. Find the value of x. I just have to create an equation. 132 minus 6x equals 90. I'm going to subtract 132. I've got some negative numbers here, but don't freak out because if you notice, I'm going to divide by a negative. So negative divided by negative is going to be positive. We don't really deal with negative numbers in geometry. So if you ever see that, most likely you're going to end up dividing by a negative, which will make it positive. Find the value of x. There's my value of x. All right, our next example. CE is the altitude 2AB. So I have to start at C and draw a segment that's going to be perpendicular. It forms a right angle. So we have to be good at estimating right angles to kind of draw it in accurately. And it wants us to name it CE. So this point right here is going to be E. And it also tells us CE equals EB. CE equals EB. So what I want to do is I'll put some tick marks on that. This side here, EB, equals this side here, CE. Now it's a very special kind of triangle. I'm hoping you guys recognize it. When two sides are the same, that's an isosceles triangle. So look at the one I highlighted. These two angles are also going to be equal. Usually we see it like this, but it's just been rotated a little bit. So let's mark those two angles equal. Now it says find the measure of angle ABC. ABC. So basically this angle right here. Well, this is kind of a cool triangle. It's isosceles because it's got two equal sides, and it has a right angle. So I know this angle right here is 90 degrees. And I know these two angles are going to be the same. So basically what I can do is I can do 180 minus 90. That gives me 90. And then take 90 divided by 2, and that's going to be 45 degrees. Each one of these angles right here has got to be 45 degrees. All right, so let's just do the math for that. 180 minus 90 equals 90, right, because this angle is 90. And then I take 90 divided by 2, and that's going to be 45 degrees. So that's what this angle is right here. Example 3, our final example, and it's a doozy. It says BD is a median of triangle ABC. So this is a median. Remember back a couple days ago we said a median goes to a midpoint. That's going to be the midpoint of this segment. So AD equals DC. All right, so let's mark those two segments congruent. So from A to D equals the distance from D to C. Now, what else does it say? BA is an altitude. Well, that's what we've been talking about today. Now, this triangle is not drawn to scale. It says BA is an altitude, which means that's a 90-degree angle. So I'm going to put that in right now. I'll use green for my angles. That's got to be 90 degrees. I know it doesn't look like it, but it states it, so it's fact. Now, one more piece of information. AB equals AD. This side here equals this side here. Well, since we said these two bottom pieces are equal, basically what they're saying is all three of these pieces are equal. B to A equals A to D equals D to C. So that is going to be congruent. Basically what that means is the distance from A to D is 17, and the distance from D to C is also 17. The question wants me to find the value of x. Well, let's take care of that first. I think I can do it right here. Since that's 17, that's 17, that's 17. Here's my equation. 2x plus 12 equals 17. Subtract 12 from both sides. 2x equals 5, divide by 2, x equals 2.5. All right, that's taken care of, pretty straightforward. Now, it says find the value of every side length and angle measure. Well, I know this is 90. I know that's 10. How do I get the rest of this figure? Well, there's one key piece of information here that we need to focus on, and that is that AB equals AD and that this is 90 degrees. Because this triangle right here that I'm highlighting is an isosceles right triangle, which means these two angles are going to be equal. And remember, what I'm going to do to calculate that is I'm going to take 180 minus 90, which is 90, and I have to divide that by 2 because both of those other angles are going to be equal. That means this angle here and that angle there are both 45. Now what you can do is you can focus on this straight line and understand that these two angles have to add to 180, so I take 180 minus 45, that's got to be 135. And then finally, look at this triangle here. That angle up top is going to be 180 minus 135 minus 10, or 180 minus 145, which is 35. Okay, so I've found every angle measure. That's done. Now I need to find every side length. Well, I've got 3. I've got this one, I've got this one, I've got this one. How do I get this here? How do I get this here? Well, let me use a different color. I'm going to say side BD equals Y. And we're going to use something from earlier in the year that deals with a right triangle and the 3 sides of a right triangle. And if you remember, that's called the Pythagorean Theorem. A squared plus B squared equals C squared, where C is the hypotenuse, the longest side. So there are my 2 legs. Here's my hypotenuse. This is going to be 17 squared plus 17 squared equals Y squared. And I'm just going to put this into my calculator exactly the way I see it there. I'm not going to bother doing 17 squared by itself. I'll just take 17 squared plus 17 squared, and that gives me 578 equals Y squared. And then remember, to solve a square, you square root it. So Y equals, I'll go nearest 10th, 24.0. All right, and finally, side BC. Side BC is also part of a right triangle. Look at the triangle I'm highlighting here. This is still a right angle, but now my 2 legs are going to be 17 and 34 because I have to put these 2 together for this whole side. So it's going to be similar. I'll use blue here, I guess. This is going to be 17 squared plus 34 squared equals, I don't know, let's call it Z. Z squared. And again, I'm just going to put this all in my calculator in one shot. Get a pretty big number. I got 1,445 equals Z squared, and I'm going to take the square root of that. Z equals, I got 38.0, so even rounded to nearest tenth, it was a 0.0. All right, so that concludes day 6 notes. You guys can go ahead and do Delta Math homework 2.6. And as always, guys, reach out if you have any questions whatsoever or want to meet for office hours. Thanks for watching. And